Okay, today we are going to talk about reactions. And there are a lot of reactions in organic chemistry. And we're just going to learn some of the basic ones, like some of the ones that you would be exposed to probably in college, just to give you a little bit of exposure. So, first one that we're going to talk about is a substitution reaction, where one or more atoms replace another atom or group of atoms in a molecule. So we have a benzene ring. And remember that the benzene ring has like hydrogens coming out of all of these carbons. And if you run this reaction where you take a methane group, a methyl chloride, and this is not really important. You don't necessarily need to remember this. This is just an example. So we substitute this CH3 group for one of the hydrogens. So like this basically comes in here and kicks that out. And then our other product is going to be hydrochloric acid. Okay, so this could be called methylbenzene, but its more common name is toluene. So then we can take toluene and we can react it with nitric acid in the presence of sulfuric acid. Again, you don't have to remember any of this, but what you get is you get that benzene ring with a CH3, and then we replace a bunch of the hydrogens with these NO2 groups. So more substitutions. Okay, we've substituted an NO2 for a hydrogen. We also make a bunch of waters. And that makes what's called trinitrotoluene, or for short, TNT, which, yes, it is that TNT. That's the explosive. So, yeah, substitution reactions, very, very common. So let's talk about the ones that I need you to memorize. And for these, you kind of need to know the conditions and you need to know the patterns, right? Like don't memorize individual reactions because it's going to get complicated, but patterns are good. So if I have, let's say that I have methane. This works with any hydrocarbon, but let's say that I have methane and I react that methane with chlorine. Now, what's going to be important for this, for you remembering this, is that this is going to be run in the presence of special light. And you remember the energy of light, of electromagnetic radiation from like way, way back in chapter 3, I think. Energy equals Planck's constant times the frequency. So this is our way of saying we're going to shine some electromagnetic radiation onto this reaction as it's happening. And when that happens, through something that we're not going to learn the mechanism for, you get a substitution where the chlorines, one of the chlorines, substitutes one of the hydrogens. My other product is HCl, but we don't really care too much about that. Now, the cool thing is I can do this again. Plus Cl2, the presence of light, and we can make another substitution. So that's a way that we can chlorinate carbons, okay, or halogenate. Um, Now, the next one that we need to do is a chlorocarbon. So chlorocarbon, which is a carbon that has a chlorine attached. When you react it with sodium hydroxide, okay, this hydroxide can come in and displace the chlorine. So it looks like, I don't care too much about the mechanism, but those electrons can go in and that chlorine comes off. So what we get something like that. Okay? So let's do a more complicated example. All right? Let's say that I want to start with ethane. And I want to make ethanol. Well, how could I do that? That's a good question. I can't do it in one step, right? Like this reaction needs a chlorocarbon, which I don't have. But I can chain the two things that we have together, the halogenation and the chlorocarbon reacting with sodium hydroxide. So what I could do is I could go react the ethane with Cl2 in the presence of electromagnetic radiation, which you do need to write. And that makes but instead of, we're going to substitute one of those hydrogens for a chlorine. Now, we also make HCl, but we don't really care too much about that one. So then we take this now, and we can react it with sodium hydroxide, and we can make that. So we can start to change some things together. And what'll make this a little harder is if I ask you to do things that are like more than one step and you have to kind of think back about like, how could I get that? All right, onwards. Addition reactions. So addition reactions are used a lot. And this first one is used all the time. All right, and that's hydrogenation. So we're going to add hydrogen across a double bond. Okay? That's what you got to remember. We're going to add hydrogens, two hydrogens across a double bond. So if we have, all right, so here, let's say, so we have a double bond. We're going to add hydrogen to it, and then we need a catalyst to run this. And our catalyst is platinum. Much like above, our catalyst was electromagnetic radiation. You got to remember that this has to be run in the presence of platinum. So if you just give me hydrogen, you don't give me platinum, it's not right. Okay? So here's my hydrogen. All right? And the way that this works is that the two electrons from the double bond come down and form a single bond with this blue hydrogen. Now that blue hydrogen now has too many things attached. So it tries to get rid of those two electrons. And where those two electrons could go because you'll notice that like when these two electrons leave to go form a bond here, this carbon now doesn't have enough things attached to it. So the two electrons, so these two electrons swing down, these two electrons swing up here to now make this carbon have 4 things attached again. So we get and so I have my blue hydrogen attached, my other hydrogen attached. Okay, so this is addition. So we're going to add an addition reaction. We're going to add 2 parts of a molecule across a double bond. Okay, so both parts of the thing go into the molecule. So here's another one. This is hydration, where we're going to add water across a double bond. Okay, so let's say we have same thing. And I'm going to put my HOH down here. Okay, so we're still going to do this. Now this one doesn't use platinum. You have to heat it pretty high, but doesn't use a catalyst per se. Oh, messed that up a little bit. Okay, so this makes an alcohol. Okay, and this is not ethene, by the way. That's wrong. Okay, but this is a hydration reaction. We've added water across a double bond to give you an alcohol. Okay, so you'll notice that we made this alcohol up here. We could also do this by taking a double bond, if we had a way to make ethene, then we could make ethanol. Okay? All right. So, another addition reaction. Okay? Now, the thing that's a little confusing is this is going to look very similar to something that we've seen before, except for this time, the chlorine atoms are going to both be attached. So that's going to make okay. So if we shine light on it, that's going to be elimination. Okay. If we're just adding Cl2 to something that has a double or triple bond, you could add you can add both chlorines in. Okay. The other thing that we can add is HX, where X is just some halogen. So that's fluorine, chlorine, bromine, iodine. Okay, so we're going to add hydrofluoric acid across this double bond. So that's going to be C, H, 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 C, F, H, H. Okay, so now we've added the hydrogen to here and the fluorine to here. It gets added across the double bond. Okay, so sort of the opposite of addition reactions are elimination reactions. And elimination reactions are one in which a simple molecule is formed and removed from a larger molecule. So we did hydration. We can do dehydration to make a double bond. So let's say we have this one. So we have an alcohol. Okay. Now this one you also need to remember. This is run in the presence of sulfuric acid and a lot of heat. Okay, and what happens is those electrons snap down to make our double bond, and then these electrons attach here. So what we get, you'll notice that this is really just the opposite of that addition reaction. Okay? Loss of HX. Same conditions. Let's do iodine this time, just for giggles. Okay, same conditions, H2SO4 and heat. And that's going to make us do, we're going to eliminate okay, something like that. We're going to eliminate hydroiodic acid. Okay, now the next one that we're going to do, condensation reactions. Two molecules are parts of the same molecule combined. Usually, a molecule such as water is removed. So we've already talked about one of these last time, which is an esterification reaction. So I take an carboxylic acid plus some sort of alcohol, okay? And we're gonna condense, we're gonna take these two things and make one molecule out of them, one big molecule. Okay, so we go CH3. So here's our carbonyl. Now we're gonna kind of switch what's attached, right? We're gonna attach to this carbon. This is where the reaction happens. So we're gonna lose these two things, which are gonna make a water. Okay, so this is going to come in and attach here. So we've got OCH3. Okay, so usually a small molecule such as water is removed. So that makes an ester, right? Oh, oops. There's our ester, right? There's our ester. And yeah, so it's an esterification reaction. A carboxylic acid and an alcohol. So you just got to remember that one. The other one is an amide synthesis. So a carboxylic acid plus an amine, which has oops, what is going on? CH3. And this, we're going to eliminate water once again. Okay, we're going to get rid of this, and we're going to get rid of one of those hydrogens. Okay, so we're going to get rid of water again. And now we're going to have our carbonyl carbon, and then our nitrogen, the lone pair on the nitrogen, is going to attach right in there. So we're going to get N, and we're going to lose one of the hydrogens. So we're going to form this. Okay, here's our amide, okay, or amide, depending on who's teaching your class. Okay, so those are all the reactions that you need to know. The condensation reactions, where you have a carboxylic acid reacting with either an alcohol or an amine. You have the elimination reactions, which the ones that I'm going to ask you for are going to use sulfuric acid and heat as catalysts. So you could eliminate water or HX. And then you have the addition, where you add two parts of a molecule across a double bond. Um, and you have substitution, where one part of a molecule is going to get substituted into another molecule. That's it for reactions for today.